My dear students, in the previous video, I have solved first 4 sums in the exercise 2.5. Now, in this video, I am going to continue the exercise 2.5 and problem number 5 we are going to solve. Exercise 2.5, problem number 5. In this problem, modulus of z is given. Mod of z is 1. Modulus of z is 1. And they ask you to show that 2 less than or equal to mod z square minus 3, which is again less than or equal to 4. We have to prove this inequality if modulus of z is 1 given. We know from our inequality principles, properties of modulus, modulus of z1 minus z2 is greater than or equal to modulus of mod z1 minus mod z2. You know the result. Already we derived this result also. So our problem is modulus of z square minus 3, which is greater than or equal to modulus of z1 is z square minus z2 is 3. Modulus of z1 and modulus of 3. This is again greater than or equal to modulus of mod z the whole square minus modulus of 3 is 3. Which is again greater than or equal to modulus of z square, modulus of z is 1. 1 square minus 3. 1 square is 1. 1 minus 3 is minus 2. Modulus value is 2. Which is greater than or equal to 2. So modulus of z square minus 3 is greater than or equal to 2. See, modulus of z square minus 3 is greater than or equal to 2. Left side we derived. We rewrite this as 2 less than or equal to modulus of z square minus 3. See, the above equation as rewrite by 2 less than or equal to modulus of z square minus 3. You consider this is as equation 1. Next, come to that side. We know triangle inequality, mod of z1 plus z2 is less than or equal to modulus of z1 plus modulus of z2. This is the inequality, triangle inequality. So, to prove the right hand side result, this modulus of z square minus 3 is equal to, I can rewrite it by modulus of z square plus minus 3. I rewrite this z square minus 3 as mod of z square plus minus 3. Because for using this above triangle inequality, I am rewrite this equation like this. This is again less than or equal to mod of z1 plus z2 is less than or equal to mod of z square plus mod of minus 3. Mod of z1 plus mod of z2, which is less than or equal to mod of z square is 1 square plus mod of minus 3 is 3. So 3 plus 1 is 4. It is less than or equal to 4. See, modulus of z square minus 3 is less than or equal to 4. Right side answer we derived. So combining the equations 1 and 2, we derived the required result. Combining the equations 1 and 2, combining the equations 1 and 2, we derive the results 2 less than or equal to mod z square minus 3, which is again less than or equal to 4. That is the problem. We completed the problem 5. Next, we will go to the problem 6. Problem number 6 is the same method, the same principle we are we are used in the problem 5 is also used in the problem 6. Problem 6 is, if the modulus of z minus 2 by z is equal to 2, if modulus of the complex of z minus 2 by z is equal to 2, you have to prove that the greatest and the least values of mod z are root 3 plus 1 and root 3 minus 1. We have to prove, if it is given modulus of z minus 2 by z is equal to 2, we have to prove that the greatest value of mod z is root 3 plus 1 and the least value of mod z is root 3 minus 1. We are going to prove these two. For that, we will consider mod of z minus 2 by mod z. Just we have seen in the previous problem, mod of z1 minus z2 is greater than or equal to modulus of mod z1 minus mod z2, that is 2 by mod z. Modulus of z1 minus z2 is greater than or equal to modulus of mod z1 minus mod z2, just we have seen in the previous problem. The same result we are applying here. Modulus of z1 minus 2 by mod z is 2 given in the problem, it is greater than or equal to mod of modulus of z minus 2 by mod z. See, a quantity, modulus of a quantity should be less than or equal to 2 or 2 greater than or equal to modulus of mod z minus 2 by mod z. I can rewrite this step as modulus of z minus 2 by mod z. Modulus of mod z minus 2 by mod z is, from that side, less than or equal to 2. That means the quantity in the modulus is less than or equal to 2 means the unknown variable inside the modulus should be like between minus 2 to plus 2. That is minus 2 less than or equal to modulus of z minus 2 by mod z, which is less than or equal to 2. Because the absolute value of a quantity is less than or equal to 2 means that quantity lies between minus 2 to plus 2. This is the principle. Again, minus 2 less than or equal to, you can take here modulus of z as a common denominator. You will multiply in the numerator, you will mod of z square minus 2, it is again less than or equal to 2. By taking LCM in the denominator, you get mod of z is into mod z is mod z square. Now, you bring this modulus of z in the denominator mod z both to the left hand side and to the right hand side. For that I get minus 2 into mod z is less than or equal to, minus 2 into mod z is less than or equal to modulus of z square minus 2, which is again less than or equal to 2 into modulus of z. Modulus of z minus 2 into modulus of z less than or equal to modulus of z square minus 2 into is again less than or equal to 2 into mod z. This is, from this step I got that result. Now I am taking the first part, minus 2 into mod left hand side is less than or equal to modulus of mod z square minus 2. You take this minus 2 into mod z also to the right hand side. Left hand side you get 0 less than or equal to mod of z square minus 2 into mod z. If you bring to the right hand side, it is plus 2 into mod z and minus 2 already there. I am taking this minus 2 into modulus of z to the right hand side, I get plus 2 into modulus of z. This is again 0 less than or equal to modulus of z square plus 2 into mod z. I am adding 1 and subtracting 1. I am add 1 and subtract 1. Why I am adding this is, I told you, modulus of z square plus 2 into mod z plus 1 is a square plus 2 into ab plus b square form. Therefore, it is less than or equal to mod z plus 1 mod z plus 1 whole square. Minus 1 minus 2 is minus 3. You bring this minus 3 to the left hand side, it becomes plus 3. It is less than or equal to mod z plus 1 whole square. Taking square root on both sides or eliminating square on both sides, you get here root 3 is less than or equal to modulus of z plus 1. And you bring that mod 1 plus 1 also to the left hand side, it becomes root 3 minus 1 is less than or equal to mod z. Root 3 minus 1 is less than or equal to mod z. That means modulus of z is greater than or equal to root 3 minus 1. Root 3 minus 1 and above. Mod z. I can rewrite that step. See. Root 3 minus 1 minus 1 minus 2 minus 3. Yes, minus 3. That's okay. Root 3 minus 1 greater than modulus of z is greater than or equal to root 3 minus 1. That means what? Root 3 minus 1 is the least value. From this value, you will get the above value for mod z. Greater value. Mod of z is greater than or equal to root 3 plus 1. So root 3 plus 1 is the starting value. Therefore, root 3 minus 1 is the least value of modulus of z. This is the first part. And again you consider the right hand side of the expression. Mod of z square minus 2 is less than or equal to 2 into mod z. By considering the left hand side, I will get root 3 minus 1 is the least value. Now I am going to consider the right hand side expression of the inequality. Mod z square minus 2 mod z square, you bring this 2 into mod z to the left hand side, it becomes minus 2 into modulus of z and minus 2, which is less than or equal to 0. Similarly, as in the previous case, modulus of z square minus modulus of z square minus 2 into mod z, you add 1 and subtract 1, already minus 2 is here. These three terms becomes mod of z minus 1 whole square, minus 1, minus 2, minus 3, just less than or equal to 0. Again, mod of z minus 1 whole square is less than or equal to the minus 3. While you bring it to the right hand side, it becomes plus 3. And taking square root on both sides, mod z minus 1 is less than or equal to root 3. And minus 1, if you bring to that right hand side, it becomes mod z is less than or equal to here. What is it? Mod z is less than or equal to root 3 minus 1. While you bring it to the right hand side, it becomes plus 1. So here mod z is greater than or equal to root 3 minus 1. Therefore, it is the least value. Here mod z is less than or equal to root 3 plus 1. So lesser values from root 3 plus 1, this modulus we can have here, if I consider the right hand side. Therefore, it is the least value. Mod z is less than or equal to root 3 plus 1. It means root 3 plus 1 is the greatest value. From that value is the initial value, and above all the values are there for mod z. greater than root 3 plus 1. Less than or equal to root 3 plus 1 means it is the greatest value. All values are below the root 3 plus 1. Greatest value of mod is that. That's all about the problem 6. Least value. We derived the problem. Next, we will solve the seventh sum in the exercise. Problem 7 is also modulus of three complex numbers Z1, Z2, Z3 are given. See, I like. Okay, seventh problem. If modulus of Z1 is 1, modulus of Z2 is 2, and modulus of Z2 is 2, and modulus of Z3 is equal to 3, also modulus of Z1 plus Z2 plus Z3 is also 1. These four conditions are given. Modulus of Z1 1, Z2 2, modulus of Z3 is 3, and modulus of Z1 plus Z2 plus Z3 is 1. Using this idea, you have to prove that modulus of 9 into Z1 into Z2 plus 4 into Z1 into Z3 plus Z2 into Z3 equal to 6. You have to prove this result. Here we have given mod of Z1 is 1, squaring both sides, mod Z1 square is also 1. Z1 square, mod of Z1 square is by property Z1 bar is equal to 1. Modulus of a quantity Z square is Z bar, you know the property. Therefore Z1 bar equal to 1. So Z1 bar equal to 1 by Z1. Similarly, mod of Z2 equal to 2. Modulus of Z2 square is squaring both sides is 4. This is also Z2 bar equal to 4. So Z2 bar equal to 4 by Z2. Similarly, from the expression mod of Z3 bar equal to 9 by Z3. We have. Similarly, we can prove by using this. Z3 bar is 9 by Z3. Here, to prove this result, we are considering the expression modulus of 9 into Z1 into Z2 plus 4 into Z1 into Z3 plus Z2 into Z3 equal to, you multiply by Z1, Z2, Z3 and divide each term by Z1, Z2, Z3. That is 9 Z1, Z2 by Z1 into Z2 into Z3 plus 4 Z1 into Z3 by Z1 into Z2 into Z3 plus Z2 into Z3 by Z1 into Z2 into Z3. See, you divide each and every term by Z1, Z2, Z3. Z1, Z2 and Z3. To compensate it, I multiply the entire term by Z1, Z2, Z3. Multiplying the term and dividing by Z1, Z2, Z3. The same term. So that is again equal to, you split the modulus Z1, Z2, Z3. Now this is modulus of Z1, Z2 cancel both in the numerator and denominator. I will get 9 by Z3 plus Z1, Z3 cancel, you will get 4 by Z2. Similarly, Z1, Z2 cancel, Z3 cancel, Z2, Z3, you will get 1 by Z2. This is mod of Z1, we can split mod of Z1 into modulus of Z2 modulus of Z3. We can split the product, and this is mod of 9 by Z3 is Z3 bar, 4 by Z2 is Z2 bar, 1 by Z1 is Z1 bar. This is 1. The mod of Z1 is 1, this is 2 into 3. Here this is total mod of Z1, Z2, Z3. The conjugate can be taken throughout the sum. And this again equal to conjugate is nothing but this is 6 into mod of Z1 plus Z2 plus Z3. Modulus of a number and its conjugate are equal. Therefore, this is Z mod of Z1 plus Z2 plus Z3 is equal to mod of Z1 plus Z2 plus Z3 bar. Therefore, they are equal, and this is one given in the problem. Therefore, this is 6 into 1 equal to 6. Answer proved. That's all about the problem. We will solve the next sum in the next video. Thank you.